Welcome back to another episode with our podcast, the TapRooT Podcast. I'm here with Alex Paradies. We're going to talk about situational awareness. Hey, Alex.
Surprise!
Ah! So tell me more about the discussion. I know you wrote a blog article. Is lack of situational awareness a root cause?
Yeah, and I do a couple talks on this too. The concept of situational awareness, I think, is an important one. A lot of times on LinkedIn and other social media, you see all these videos, and you'll see somebody was not paying attention, and they get hit by something. They get hit by a vehicle, by a truck, a dropped object, and I always see the same comment again and again, which is they had a lack of situational awareness. They should have had better situational awareness. I think people often misunderstand what situational awareness is, and they get it confused with, I think, spidey sense and a precognition, because it's not that. It's a skill in some cases, but it's also, there's something deep to human factors about understanding situational awareness.
Mm-hmm. Okay. So I'm just interested in a little bit more of what you think situational awareness is, if it's not those things. What's your definition?
So there's two good definitions out there that are not my personal. These are written by researchers in the situational awareness field. The first is by Inslee, and she has the idea that situational awareness is the perception of elements in the environment within a volume of time, the ability to comprehend their meaning and project their status in the near future. So basically she's saying, okay, we've got to be able to get information, figure out what it means, and figure out what's going to happen next. And that process is situational awareness. Mm-hmm. Champion has it a little bit easier. He has it as the ability to extract, integrate, assess, and act upon task-relevant information.
The acting part is definitely something I would agree with. It's just being like almost reactionary to whatever that stimuli is.
Yeah, and I think tying it to a task-specific thing is key. So there's a video, you might remember some of these. They were commercials that came out post 9/11, and they were done by Homeland Security, and they were, if you see something, say something videos. I always like one, and I'll get us to put it up in a little box to show it in the corner. But basically, the video goes, "Hey, I want you to keep track of the number of subs that were handed out."
Like sub sandwiches.
Yeah, sub sandwiches. Okay. And they start handing out these sub sandwiches, and you're trying to track them. 1, 2, 1, 3, 4. Oh, no, that one's not a person in an orange shirt, so I don't count them. And you're trying to count these things, and in the background, there's all these things happening. Yeah. You see the pizza truck becomes an ice cream truck, and this thing happens and that. And there's this person that drops off a duffel bag and leaves. And the purpose of it was, you're going to miss things if you're not looking for them. But I think that video is a really interesting one. So when I present this, I always have people count how many and raise their hand and see who got it right. And what I've always found is there's people that recognize that it's a trick.
Yeah.
And so they're not counting at all. But they see things like the pizza truck change. They don't always notice the duffel bag. That's rare, because most people aren't looking for that when they start these videos. They're famously looking for the dancing gorilla. I don't know if you've ever seen that video. That's the other attention to detail one. A bunch of people passing a basketball around, and there's a dancing gorilla moves through the object while you're counting.
I saw that one, but yeah.
So to me, what stands out in that is you get these two groups. You get the group that focuses on counting the sub sandwiches, and that group has a mix in how many people get it right and wrong, and that happens. There's mistakes get made. Then you have the group that focused on what was happening else than that. Well, that group 100% gets the wrong answer with how many sub sandwiches, because they weren't paying attention. So they fail the task at hand, which is count the subs.
Naturally.
The other group might get them out right, but they miss all this other information.
Right.
And so when you understand situational awareness, you're really understanding that it's task relevant. And you're never going to create people that can just perceive everything. we're not Jason Bourne. We're not just, recording all those elements and figuring it out. You've got to look at how we collect, organize, perceive information, understand it, and take action on it.
Right. So great definition. Thanks for clarity on that. But we're also tying this into root cause analysis. So we've defined situational awareness. What's the kind of the deeper dive that you've got here today you want to talk about?
So I think from a root cause standpoint, and that was my article that I had wrote forever ago. I think people misunderstand. They think situational awareness is a root cause. It's not. It's the start of an investigation. It tends to be some element of the causal factor, that somebody didn't see something so they didn't take a specific action. But it's not a root cause of that. It's a starting of a human performance difficulty. And so in TapRooT, we look at the starting point being human performance difficulty, equipment difficulty, natural disaster. It's the third question on there: was there a situational awareness issue? So that leads us down into looking at human performance. So when you're doing that, you need to look at those three things. So there's three elements to a situational awareness. There's perception, there's comprehension, and there's projection. So you have to have those three elements, and you have to look at how we set people up for success or failure with regard to those three elements. So when we think about basically, your first is perceive, right? How do I perceive information? You familiar with the Miracle on the Hudson?
No.
So there was a airplane that was taking off.
They made a movie about it.
They did.
Okay. Yeah, just like Jason Bourne you mentioned earlier.
Yes.
When we're talking movies, I gotcha.
Now you're thinking it's Sully.
All right.
And so that airplane takes off. They hit a group of birds, and it takes out both engines. So when we think about perception, comprehension, and projection, the first thing is you have to perceive information. You get information from your surroundings. So they're flying the plane, normal takeoff, hits the birds. Okay, what am I getting for information? I feel it. I can see birds. I can get sensory information from my sensors. Okay, I've got one engine down. I've got two engines down.
That's the perception of the hazard or the danger.
Yeah, well, it's seeing information. You may not recognize it as a hazard just yet. That ties into the second, which is comprehension. What does this mean?
Okay.
What does I get this input? What does it actually mean? Well, the pilots are now trying to process this. Okay, I've got one engine down. I've got two engine downs. What does this mean for my descent rate? How much time do I have left? They're starting to comprehend the situation they're in, and that's where they start to project. So that third element is projection. What's going to happen in the near-term future? I'm going to descend at this rate. Can I make these moves? And this is it's a loop, because you're constantly taking actions and you're constantly getting feedback. So we look at how we get this information, how we comprehend it, and how we interact with our environment as a feedback loop. So in the case of the Miracle of the Hudson, they radio in, they're given coordinates to make a turn to Teterboro, and they can't make that. They comprehend it, they think, assess it, they say, they project, go, no, I don't have enough altitude for that. What's my next option? And so they do this assessment process until they come to the conclusion there's no options available, we've got to make a water landing. And that process can be micro, as in fast, and it can be slow over a few minutes. As we get new information, we reassess and we update our projections. But there's an element of timeliness to it. So a lot of people, again, you're not going to deal with situational awareness in the split-second reaction to something. You have to look at it as a system of getting information, comprehending that, and projecting. And how do we slow that process down to give people the time to get the information, comprehend it, and make accurate projections?
Okay.
The faster you have to make those, either the better you have to be or the luckier you have to be. And so, again, if we can slow it down some, it helps us better process through and understand these.
So I don't fly an airplane, clearly. What is another example, just a brief example of kind of what you've explained that doesn't have to do with airplanes and birds and engines that somebody else might encounter as a kind of a wake up to an example of situational awareness?
Yeah, so you can apply this to any task that's being performed. There was a study done by Inslee, and she looked at air traffic controllers. So again, I'm going to hit aviation, and then I'm going to go even further away.
Okay.
But she was looking at the people that were monitoring airplanes. So altitudes, other things. What they would do is they would look at air rates, and when they made a mistake, they would look at which of those three elements did they make. Was it a lack of perception? Basically, they didn't see that there was a problem. Was it a lack of comprehension? They didn't register that it was a problem? Or was it a lack of projection, as in they didn't see what was going to happen next?
Okay.
And so they look at those error rates, and what they found was in this study with this task, about 78% were related to perception, meaning they didn't see the error. And so when we think about our tasks, and I think this is not 100% across the board, it's always going to be perception, but I do find that one is a higher cause for most in industries and most tasks. So what you look at, if we're monitoring a piece of equipment, monitoring a system, how we get people that information. So I need to say, think about an alarm. Well, if something in our system is alarming, I need to perceive that it's an alarm. I need to recognize what the problems are that are causing that alarm, and then figure out what actions I can take to stop it or stop whatever bad outcome we want to have happen. So when we think about, again, I'm monitoring something, I get my signal, oh, there's a fire. Now, I don't want to have a person that pulls the fire alarm, but you can see that. Somebody'd see a fire, that's going to spread, I need to pull the fire alarm. That's the projection. So see it, recognize it's a danger, what's my response? Those things are what we look for, and it's true whether it's responding to an emergency or if it's just responding to everyday signals. Again, I think back to the old guy running the machine, and they were running it by vibrations and sounds. Oh, they're hearing, I feel a little bit of a vibration in there. That means I need to make an adjustment to my piece of equipment. So again, people can get that information from not just screens, but also other physical environmental indicators.
Okay. Yeah, I think that's a lot of, you started off with people getting situational awareness confused and how they define it, so it is being more aware, obviously, paying attention, having your head up, but you have to be able to recognize those things. So the perception, totally, I can see where you've got to start there.
And recognize that it's not just about telling the person to perceive more. It's really thinking about how your system sets people up for success and failure. When we think about alarms, sometimes there are just blinking lights. Well, okay, is that really going to get people's attention? A small blinking light on a giant panel. Well, can we do something that makes an auditory response, that makes a tactile response, some vibration? Is there something that can, bring it to their attention easier? And this can be true whether it's a digital item like a screen, or this can be true with its physical items. Again, when we think of that physical response to operation, how is our equipment giving signals to operators that the task has been done or that there's something wrong? In Lean, we used to call it status at a glance. So you could have an inventory system where you saw when things were getting low based on, how much inventory was visible.
Yeah.
And so you could visually see. Well, just visually seeing it's one, but if I want to make it more intuitive, again, I have something that automatically flags, automatically signals. You get so low, and there manually pops up a big flag. So again, can we, make these systems where it's easier to perceive things? Something else with perception, when we think about how do we improve it, we think about how do we make defects easier to detect. When we think about housekeeping, when things are really strewn all over the place, that's not well organized, it's difficult for people to recognize hazards, but also recognize when things are not normal. And so, again, with situational awareness, you can't tell somebody to pay more attention. I mean, you can, but it only lasts for a very short period. So you have to think about, how do you make things easier to detect problems, and good housekeeping, good organization.
That's all environmental.
Yep.
Yeah.
And so you take something from that kind of default to when there's an anomaly, when there's something different, it stands out.
Right. That makes a lot of sense. And I think that the perception, comprehension, and projection, it is like a cyclical effect. The time in between each of those in decision making can be very short. So, having to think quickly and make a accurate decision on what did I see, what does it mean, what do I do, can be challenging, especially when we're talking about some of these industries where, it's a matter of somebody's finger could get cut off or worse.
Yeah, you could end up blowing up an entire refinery because you don't have that information coming in. You don't recognize there's a problem. Tying in with that, increasing perception is going to reduce your error rate because they know there's a problem. But then you've got to look at the next two, which is comprehension and projection. So comprehension is, I got the information, but what's its significance? So I think of, there's a 3 Mile Island. So that was the nuclear disaster. One of the things that was interesting, we had at the TapRooT Summit, we actually had basically the main operator. He was the guy in charge of the control room at the time of the incident. And he spoke on kind of what the room felt like. And one of the things he talked about was the number of errors and alarms that they were getting at one time. And I don't remember the exact number. I want to say it was like 200 in the first second.
Wow.
It was a high number, and it was a very short time period. And the thing I always think about, they had this printer, and it was one of those old scroll printers, with the little
on the
perforated
sides,
edges.
the
It was
little
one of those
holes, yeah.
And it just was going off, and it took 20 minutes before the relevant alarm that they actually would have needed to know about in order to respond was even printed. That's how many alarms that they had, and talk about printing time. It was something like 20 minutes.
Crazy.
And I don't remember the exact times on this because this was about a decade ago we had him speak, but I just remember that was such an impressionable thing about, okay, I've got all these alarms coming off. What do they mean? That's something we need to think about, is how do we set people up for success when they're getting this information to understand its significance and respond appropriately.
So you have the answer for this.
Well, I know of some things.
Okay.
So when we think about this in TapRooT, we think about complex systems and non-fault tolerant systems. So when we think about complexity is basically you've got large numbers of inconsistent variables. So if you think of the stock market, it's a complex system. There's not one thing that's, driving it up and down. There's multivariables that we don't even see sometimes that are making things happen. And so when you do that, the first thing you need to do is you need to make those variables clearer. So make information more obvious. That's how you get that perception improved. So that way they get the right information in a timely manner. So what information do they need to recognize, and how do we get that information into them faster? The other thing is you need to increase the time to process. People can't process tons and tons of data. Computers are better at it, but we get too much information, we get overloaded. So giving them more time to assess, basically when you think of setting your safety factors, if I get an alarm, but I only have a split second to react to it, that's not good. So I like to think of a big old barrel, and that barrel's filling up with water. And ideally, you would have a level alarm. You're getting full. Well, if that level alarm is set, and the time it takes you to push that button, the pump would have already pumped enough water to overflow it, that time to respond is not appropriate.
Daniel Kahneman has a book on thinking fast and slow.
Yeah.
And he talks about system 1 and system 2 thinking in our brains. And so that system 1 is the quick response. But if we have more time, and it's usually in context of like law enforcement and things like that, but when we have more time, the system 2 activates and we can make better decisions. So time is our friend. But even in high stress, volatile environments like law enforcement can encounter, kind of keeping that in mind, we're going to make more mistakes generally the quicker we have to make those decisions.
Yep. And so again, if you can increase time, and from a systems, you want to make that alarm process have an appropriate level of response time so that you can recover. Mm-hmm. So we call this in fault tolerant systems. A fault tolerant system means if I make a mistake, I know about it, which means there's a way to detect that I've made a mistake, and there's time to recover from that mistake. So that's part of it, is adding that process in there, that processing time. The other aspect of it is projection. What's going to happen next? And I think it's interesting you bring up law enforcement, because I think law enforcement's one of these, when we talk about complex systems and knowledge-based decisions, it's an area where people don't recognize how much of a knowledge-based decision that officers have to make. And so we supported an investigation for a department in I won't say what state, but one of the things that it looked at was the decisions that the officers were making along the timeline of what was happening. And so when they got there, when they saw there was a problem, what was their kind of response? What should have their response been? And how did things progress? And once it hit a certain point, immediately things went wrong. But there was time beforehand where we would assess, make our plan, and take action. Mm-hmm. And so some of that is, okay, how can we train operators so that they recognize this situation beforehand? Well, their solution was they're going to do more training. And the training that they proposed, honestly, was weak, because it was basically, here's the new guidelines for how you're supposed to respond to this. It's a form and we hand it to you. Does that really train complex knowledge-based decisions?
No. Scenario-based training would be a much better avenue, in my opinion. But.
Yes. So what I call, you say scenario, I say simulation, same thing. The idea is, if you're going to train knowledge-based decisions, that's the projection element. I have to take in information in typically an emergency or an unknown situation when I don't have all the variables. Then the only way to build that skill is through simulation. And you have to do that in a safe environment. You don't do that on the job. A lot of companies make the mistake, they think, okay, my on-the-job training will teach people everything they need to know. But unless your on-the-job is constantly being in emergencies,
those variables change.
Yeah.
The outcome is not going to, every domestic response, there's so many things you can't control, you just don't know.
Yeah. Well, so most job is routine work. Most of people's work is routine, and on-the-job training is going to do really well at teaching people routine work, because they're going to get the basic stuff first. It doesn't do well for the situational and the knowledge-based work, the unroutine. If you have a job, police have a pretty high level of non-routine situations. It's routine work for them, but it's non-routine situations. So you're encountering somebody in a different location every time. You're encountering a different person, and you don't know their state as far as mental state. Are they on substances? Are they armed? A lot of unknown variables at the initial assessment of any situation. This can be true in other industries as well. So we look at, okay, if we're going to do that, you have to do a significant amount of situational training so that you give them those situations and give them the ability to fail safely. Because that's the key to training that projection, is teaching them how to project what's likely to happen and what they can do that's going to have the highest success rate. Obviously, the highest success rates don't get yourself into a situation, but again,
sometimes the job doesn't, dictate that.
Any industry will tell you that it's great if we don't ever get in those situations, but we do, and that's why we prepare. I think the simplest one that probably everybody's been through is a fire drill.
Yeah.
Why do we do a fire drill?
Practice so that when that alarm goes off, we can be like little zombies and just like know what to do. Where's our muster point? And
Instead of us panicking and running out who knows where and getting locked in some exit and burning in a fire, right? We don't want that. We want to say, okay, we're going to do a drill where it's safe, it's controlled. Everybody knows it's a drill, but they know that they're going through the motions to say this is what needs to be done. And they can practice that. And if we see problems, we can correct them. And so that's simulation. I'm going to do a drill. It's going to be safe. We're going to make sure it's successful. And if there is a problem, we then come back on it. We do our root cause analysis and we say, what do we need to change in our system to make it more successful next time?
So I now understand your difference in terminology between a simulation and scenario-based training. So I also work in security, armed and unarmed. And so in scenario-based training, it's like reactionary, almost like a video game where you can approach a suspect and you don't know what they're going to do on the other side. And so they can respond to verbal commands, and the system, the game, the training apparatus will give you a different scenario each time, so that you're learning different variables and responses, and you're also having to have situational awareness to whatever it's presenting to you in that almost like live action type scenario training. Compared to the fire drill, that's definitely something that we kind of all go through in more simulation based.
Yeah,
sure.
Well, both are simulations. The difference is how much variability comes in. So a fire drill shouldn't, I mean, I've heard of people that did like all out fire drills.
And we've got stuff popping off
I'll
firecrackers. And
I bet everybody remembers the Office episode.
that's what I was thinking of. And the cat's up in the ceiling. Yeah.
That's a true fire simulation situation. That's a bit much. Yeah. I think most people just don't go through that level of theatrics for theirs. But again, depending on what you're wanting to train on, again, is this something that's going to be high variability? And police officers, for example, or military, they are constantly dealing with a high level of variability, so they have to do even more extreme levels of training. And it's one of the biggest things that you notice that goes away first, honestly, is that level of simulation for training. And when that goes away, the number of mistakes when it comes to perception, comprehension, and projection increase. So if you've got an industry or you've got a job that has a high level of knowledge-based decisions where people are working on uncertainty and in uncertain situations, you need to do more simulation-based training. I was talking with a logging company, and one of the things about cutting down trees with a chainsaw is every tree is different. They don't all react the same way. Some of them, they may look perfect on the outside, but they've got a rotten core. Some of them have knots in them that cause it to splinter in ways that you don't expect. And so when they train people, most of what they do is train on the job, and you have a senior person that's giving them the most advice they can, and you train them as best possible and teach them how to react and put in place things to make it fail as safe as possible. But they have to learn by dealing with those situations. And when you have a high turnover job, like the logging industry is, it's hard to build that expertise over, you don't have as many people that are 20, 30 years in that job. So you don't have that deep expertise. So again, that conversation with them was, well, okay, how could you create more safe training that's teaching them these hands-on, that's not just on the job, but like identified and tasked in a way that, for training. And so they were thinking about, hey, what could we do to create these scenarios where they have them practice on things in a safe environment. So again, you almost think like a dummy tree. They were like, oh, I could do a dummy tree and like have it like actually be something real. Again, that's the kind of thing we think about, is how do we take those lessons from simulation training and how do we apply it to our industry?
And what I'm hearing through this too, whether it's aviation or law enforcement or logging, these high-risk jobs that we also have to consider the situational awareness in the low level as well. We have to be ready for everything and anything, and not just say, oh, well, I have the most low risk job, I don't really need to pay attention, I don't have to have that situational awareness. Like, it's everywhere.
Yeah, and we talk about this in our Stopping Human Error course, which we look at things like attention to detail. We look at things like questioning attitude, and what role do those play in people's ability to detect mistakes and to detect errors and respond appropriately. And so when I think about trying to teach people from a human performance perspective, these are the kinds of things I think about. How do we make mistakes, make errors more obvious? How do we get them more information so that they can understand that a mistake has been made and understand what they need to do to respond to that situation, respond to that error safely? Because we know mistakes are going to be made by people. It's human nature. So the question is, how do we teach them to recognize? How do we make the system, more importantly, how do we make the system make error detectable and make there a recoverable response so that people can take the right actions? So again, that our human error course really breaks that down and makes it kind of a actual plan that you can use for how to approach the human-machine interface, the human and system interface. So we go through those kind of concepts as well. And I know you know that because you're going to be teaching the course with me coming up. So I think it's a good opportunity for people to learn.
Oh, yeah, and to look at the system without the finger pointing and to solve the problems. And what I love about the course, too, is it's not like, all right, here you go, this is what you need to do. It lays out all these different options, and so for your industry, you're able to say, I think we want to try this approach.
Yeah.
So there's a lot of flexibility in that as well.
Yeah, because again, some industries are going to deal with a lot higher amount of variability in their work, a lot more uncertainty in their situations, and some industries are going to have more routine, more procedural tasks. And so what techniques are going to be best for each of those elements? How can we make our systems more intuitive, more easy? We go through all of those. So I highly recommend that people check out the options for that course. Again, you can check out the Stopping Human Error course on our website. There'll be a link down below that they can click on to see what the course is about and see the next available course when it's coming up. We do them a couple times a year generally, so check out which one's closest to you and which one's coming up in your area.
It's the best 2 days that you'll have training. So, well, Alex, before we close, is there anything else you want to add? Anything we need to cover that we didn't address?
I think everybody here has better awareness now than they did a minute ago.
Yeah. All right. Well, thank you for joining me today, and thank you for listening or watching another TapRooT podcast. We'll see you next time.
Make sure you hit the subscribe and notification buttons and follow on other social media.
Yeah, we're on all the socials.